In the figure below, point O is the center of the circumcircle of triangle ABC. And the bisector of angle A is extended to meet the circle at P. Prove that the radius OP is perpendicular to BC. So let's go ahead and start this proof. Okay, so circle O circumscribes triangle ABC. And we have that AP, this line AP, bisects angle A, which of course implies that the angle of BAP is congruent to the angle of CAP. Right? That means that these two angles are congruent, right? Well, of course, this implies that the measure of angle BAP is equal to the measure of angle CAP. And since these are both inscribed angles, this implies that half the measure of arc BP is equal to half the measure of arc CP. And then, of course, if we multiply both sides of the equation by 2, we get that the measure of arc BP is equal to the measure of arc CP. And then, of course, this implies that BP is congruent to CP. Right? Now, we're going to let T be the point where OP and BC meet. Right? So OP and BC is going to be this point here, point T. So we're also going to extend OP to point Q, which is an element of circle O. So we're just going to draw this right here. We're going to extend it, right? And this will be point Q. So by linear pair, I know that the measure of angle BTP plus the measure of angle CTP is equal to 180 because they form 180 degrees, right? All right, since QP, right, is a diameter for circle O, right? Clearly, QP is a diameter because it is a chord that goes through the center, right? We know that the measure of arc QBP, right? QBP is equal to 180, which is equal to the measure of arc QCP. Okay? And then, of course, this implies that the measure of arc QBP is equal to the measure of arc QCP. All right? And then QBP is equal to the measure of QB, the arc QB, plus the measure of arc BP. And that's equal to the measure of arc QC plus the measure of arc CP. Right? So remember, we had BP, arc BP, was congruent to arc CP, right? So of course, this implies that if these two are equal, this implies that the measure of QB is equal to the measure of QC. If BP and CP are the same, we can just subtract the same quantity from both sides to get these are the same. So then, of course, this implies that QB is congruent to QC. Now, we know the measure of angle BTP. So BTP is equal to half of arc BP plus half of arc QC, right? So this is equal to half the measure of BP, right, plus QC. Well, I proved that QC is the same thing as QB, right? So I know this is equal to half the measure of BP plus the measure of QB. Now the reason why I did that is because BP plus QB is 180, because that's a semicircle of this circle O, right? So this is equal to half of 180, which of course is equal to 90. So I know the measure of angle BTP, right, is 90. Well, all right, now I know that CTP must also be 90, right? So by linear pair, which is what I had above here, right? I know that BTP plus CTP is 180, but now I know that BTP is 90. So I know that 90 plus the measure of angle CTP is equal to 180, which implies that the measure of angle CTP is equal to 90, right? So now I have this is also equal to 90, right? So of course, this means that BC or OP is perpendicular to BC. Which is exactly what we wanted to prove. We wanted to prove that the radius OP is perpendicular to BC. That is the proof.